Hello guys, good morning. Good morning to all of you. Can you hear me properly? Good morning to all of you. Can you hear? Is everything all right? So today we'll be discussing the fourth part of the mathematical tools of quantum mechanics. Without any further ado, let's start. Good morning, Murli. So mainly in today's session we'll be solving problems, a lot of problems. Look at this problem. An operator representing an observable for a two-state system is given by this. So A is equals to alpha times, you see, product of kit and bra is given and summation of them is given. Phi 1 is given to you, it is a kit, it's a column vector. Phi 2, it another kit, this is also a column vector. Its eigenvalue and eigenvectors are given by. So what basically this problem asks you to do, it asks you to formulate, to represent this operator A in the matrix form. Once you express it in matrix form, you can easily find out the eigenvalue and eigenvectors the way we have done it in mathematical methods. That's it. Can you do this? Give it a try. Simple question. Look, as per the given question, what will be the value of A? A is equals to alpha. Alpha is a constant. Let's keep it as it is. It is kit phi 1. Kit phi 1 is column vector 1 0. So what will be bra phi 1? Bra phi 1 will be a row vector, right? And these are all real elements. So simply 1 0. Similarly, bra phi 2 will be 0 1. Plus phi 1 phi 2 kit phi 2 bra phi 2 plus kit phi 1 bra phi 2 and then phi 2 phi 1 kit phi 2 bra phi 1. Okay, Harry, good morning. Give it a try, okay? So what is the matrix effectively? If you multiply this, what elements you get? 1 and all the elements are 0. Here, if you do this matrix multiplication, then what you get? 1, all the matrix elements are 0. Here it is 1 and okay. So you are getting this is equals to alpha times you are getting, let's say, 1 and all the elements are 0. From the second one, what are you getting? 0 0 0 1. From the third, you are getting 0 1 0 0. Now from the fourth one, you get 0 0 1 0. Are you getting in this way? So if you just add them up and multiply alpha, you see 1 1 1 1. So it is alpha 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 isn't it? So now you got the operator in the matrix format, matrix representation. You have to find out its eigenvalue and eigenvector. This process is very simple. Just calculate the eigenvalue and eigenvector. So we need to formulate the characteristic equation A minus lambda I equals to 0. So to get eigenvalue, so A minus lambda I equals to 0 gives you alpha minus lambda, and this alpha will remain as it is. So this is alpha minus lambda whole square minus alpha square equals to 0. That means you see alpha minus lambda plus alpha, a square minus b square formula, alpha minus lambda plus alpha, this is equals to 0. So this is giving you alpha is equals to, first is 2 alpha and second is also 2 alpha. Acha, oh, both the terms you have written the same, minus plus. Okay, so one term is giving you 0, another one is 2 alpha, right? Now we have to find out the eigenvectors corresponding to this. How to calculate that eigenvectors? So let's say lambda 1 equals to 0 and lambda 2 is equals to 12. Let us calculate the eigenvector corresponding to lambda 1 is equals to 0. So lambda 1 equals to 0, how to calculate the eigenvectors? So let's say the eigenvector is x1, x2. So alpha, x1, x2. So ax is equals to lambda x. Lambda is 0 here. So we are using this form. A x1, let's say, is equals to lambda 1 x1. Well, lambda 1 is the eigenvalue, x1 is the eigenvector. Okay. Now as you can see, this is 0. So from this, what you can write? We can write x1 is equals to minus x2. So using this, what will be the eigenvector? If x1 is equals to minus x2, so if you take, let's say x1 is equals to 1, x2 will be equals to minus 1. Okay. Or if you take x1 is equals to k, because this is an arbitrary relation, so x2 will be minus k. Now using this, we can use the normalization condition x1 dagger, x1 equals to 1. So this will give you, look, x1 dagger means k minus k, x1 that is also k minus k. So one will be row vector, another will be column vector. So this will give you k square plus k square. So 2k square equals to 1. It means k is equals to 1 upon root 2. And as a result of that, your eigenvector corresponding to lambda 1 will be x1 is equals to 1 by root 2, 1 minus 1. Okay. So I have just illustrated how you can calculate the eigenvector. Now let's go for 2 alpha. So if you go for 2 alpha, so you can use this logic again, ax2 is equals to lambda 2 x2. So a is alpha, x2 is x1, x2, lambda 2 is 2 alpha times x1, x2. And if you do it in this similar way, you will end up getting that x1 is equals to x2. And as a result of that, x2 will come out to be 1 upon root 2, 1, 1. And this is matching with option D. Let me know if you have any question or confusion on this problem. Anyone has any doubt? Now, okay, let me tell you one of the approach to calculate to decide whether one operator is Hermitian or not. You know, when I am giving you, let's say IA or something like that, you can easily take dagger and you can tell whether it is Hermitian or not. Now, some of the operators are there for which you cannot directly tell about its hermiticity. So, how to check whether an operator is Hermitian or not? This is a good question. How to check whether an operator is Hermitian? So, sometimes taking dagger is not possible. For an example, if I am giving you, let's say, what about ddx? If I am giving you an operator ddx, can you tell me whether it is Hermitian or not? By taking dagger, it is not clear that whether it will be Hermitian or Hermitian, not non-Hermitian. So, for this type of case, what you can do? Look, let's say if you have an operator A, the simple check is A dagger should be A to call A to be Hermitian. This is the basic criteria, right? Now, what we can do, this condition can alternatively expressed as psi A psi is equals to A psi psi. So, if this criteria holds, then we can say that A is Hermitian. Is Hermitian. Now, if you see that psi A psi is equals to minus A psi psi, then we will call it anti-Hermitian. So, these are the two checks. Right? Let us take the example of ddx. ddx, we want to check whether it is Hermitian or not. So, what is the criteria? We have to show that psi Si should be represented in this way, Si psi. So, psi A is the operator here, which is ddx psi, and you know the meaning of it. What is the meaning? So, bra psi. So, this will be psi star ddx, this is ket psi, and dx integration, and the limit of x is minus infinity to plus infinity. Can we write it in this way? No issue in this. Now you can see it is like the product of it is like u v dx, where u is psi star, v is d psi by dx. So integration of u v dx, so partial integration by parts, sorry, integration by parts formula we can use. So u integration v dx, so d psi by dx time dx, minus integration du dx, so d psi star dx, du dx integration v dx, d psi by dx dx, integration v dx, then we multiply dx. So this is how you do integration by parts. You can look at the formula from a class 12 book if you are not able to understand it. This is equals to, you see psi star, and this will give you psi at minus infinity plus infinity, you know this term is 0, minus infinity plus infinity, this is again d psi star by dx cancel, integration of d psi is psi, so psi dx. The first term is 0, okay, and the second term, let's write plus, we are taking this minus inside, so minus d psi star dx into psi dx. So you see what the way we write this, you see this is nothing but dd minus d psi dx psi. Can I write it? Therefore, what is the nature of d dx? d dx is an anti-Hermitian operator. Is it understood? In this way, if you go for, let's say, d square by dx square, by following the same approach, you will find out this to be Hermitian. Can you write the general formula how you proceed with this integration? That this is a class 12 formula, u v dx, okay, u integration v dx minus du dx integration v dx dx. This is the formula, right? Is it clear now, Karthik? In this integration, u is psi star and v is d psi by dx. Odd skew Hermitian, if it is even Hermitian is follow. No. If there appears a negative sign, the way you see a dagger is equals to minus a. So negative sign appears. So here you see a negative sign will appear if it is skew Hermitian or anti-Hermitian. If it is positive, then it will be Hermitian. So here you can see a negative sign appears. So that is why it is anti-Hermitian. If this negative sign was not there, then it could have been Hermitian. Okay, Hari? It's not about even odd. Even odd concept is not here. Harry, is it okay? So you can try with another operators to check whether it is Hermitian or anti-Hermitian, and if you are given a simple expression, then you can simply use a dagger equals to a, taking dagger on both sides. But for this kind of operators, things remain a little bit things becomes a little bit challenging. So d dx is anti-Hermitian. If it is minus d dx will be Hermitian, you can see, because the minus sign is there. If you can observe somehow the minus sign, so if even though d dx is anti-Hermitian, minus d dx will be Hermitian, as simple as that. D square by dx square is even. No, it doesn't work in that way. D square dx square, that is an operator. How can you say whether an operator is even or odd? Let's say if it operates on, let's say, x cube, then this will be t dx of 3x square. So this will be 6x. So this is odd, right? So this is the operator, not, you should not call it whether it is even or odd. That concept is not applicable here. Let us move to this problem. Consider the operator a is equals to x square plus d square by dx square acting on a smooth function of x, the commutator of a cos alpha x each. Look, whenever you see this kind of operator and commutator, you should apply it on some wave function psi. So let's say you apply cos a cos alpha x, you have to apply on some wave function psi. Just a moment. हाँ मैम, वो फोन नहीं उठाए, मैंने मैसेज कर दिया है उनको. लेट्स सी, ही विल कॉल यू. हाँ 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 हाँ, आई अंडरस्टैंड. हाँ, मैंने मैसेज कर दिया है और फ़ोन भी कर दिया है, तो आई थिंक यू विल कॉल यू सून. हाँ हाँ. Oh, d to the power 4 by dx to the power is also even. Yeah, we have to check it if it is giving that kind of result. Yeah, that may be a sign. Okay, let's do it. A cos alpha x psi x. So you see, let's say you get some result times psi x. Then the value of this operator commutator will be this. In this way you have to do. If you do not apply it on operator, you will get wrong result. So let's do it. So first of all, let us simplify this little bit, then we'll apply it on wave function psi. So a cos alpha x. So this is equals to, a is given to you x square plus d square by dx square cos alpha x. Okay, so you can simply use x square cos alpha x, this is a commutation of x square cos alpha x, plus d square by dx square cos alpha x. So these are simply algebraic function x square and cos alpha x. So whether you keep cos before or after, or you keep x square before or after, this will be 0, right? So ultimately we have to check for this operator. So whenever you see this kind of operator thing like d dx, d square, dx square and all those things, you have to apply on wave some function. So this is not necessarily be a wave function, it is any function. Okay, so we have to calculate this part. For that we need to apply it on some function. So d square by dx square cos alpha x. Let's apply it psi on psi of x. So what will be this value? You see, firstly d square by dx square cos alpha x psi x minus cos alpha x d square psi by dx square. Why psi multiplying psi is important? Because you see, if psi was not multiplied, then d square by dx square would have been alone. There would have been nothing to apply one. Okay, and at the end we'll take care of. We'll take this psi common, and from both sides we will remove psi. Okay, so this is equals to. So here you see d square by dx square cos alpha x side. So this derivative of this whole thing. So let's do it one time derivative. So d dx. Now derivative one time cos alpha x minus alpha sin alpha x psi of x. Next, keeping cos alpha x fixed, then d psi by dx, and this remains as it is, minus cos alpha x d square psi by dx square. Clear? Now we have to take derivative with respect to x. So this is minus alpha square cos alpha x psi x. Another term will come minus alpha sin alpha x d psi by dx. This one plus cos alpha x d square psi by dx square, and minus alpha sin alpha x d psi by dx minus cos alpha x d square psi by dx square. Now this thing and this thing getting cancelled, and minus alpha square cos alpha x psi of x minus alpha sin x, or 2 alpha sin alpha x d psi by dx. So you can write it in this way, minus alpha square cos alpha x minus 2 alpha sin alpha x d dx of psi x. So this is x square, sorry, x square or a cos alpha x, a cos alpha x becomes minus alpha square cos alpha x minus 2 alpha sin alpha x d dx, and that is matching with option C. Is it crystal clear, guys? Tell me. Let's go for the next problem. An operator A is defined as this. It is given that ui, uj, delta ij, state psi can be represented in the basis of ui. If A is measured on psi, what will be the measurement? So we have done actually exactly this problem. So we have already calculated A. Now if A is measured on state psi, what will be the measurement? It means, what is the measurement? A will be coming in the matrix form, the measurement will be its eigenvalue. Okay, so indirectly it is asking you to represent this operator A in the matrix format, and you have to find out the eigenvalue. So do it quickly. Tell me the answer quickly. Is it solved? I think the same problem we did with this, we have done already up to formatting A. Oh, it was what it was? Anti-diagonal, na? So 1, 1, 1. I think we did it in the last class. So we got something like this. Now what we have to do, we have to find out the eigenvalue of this thing, right? Minus lambda, 1 minus lambda, minus lambda, 0, 1, 0, 0, 1, 0. Minus lambda square, 1 minus lambda, minus 1 minus lambda. You got it something like this, right? 1 minus lambda, lambda square minus 1. Lambda, from the first one we are getting 1, from the second one we are getting plus minus 1. 1, 1 minus 1. B. Yes, B is the option. Correct option. Look, let me give you a simple trick or formula. You know it, right? X px. What is the commutation of x px? You already know this is I h cut, right? You know it. Px x will be minus I h cut. Px x will be minus. Just remember this one. This we can automatically write. Okay. Now, if you are given x px to the power n, then what will be the formula? The formula will be n I h cut, and whatever power will be there, the power will be reduced by 1 unit. N I h cut px to the power n minus 1. Similar thing, if the power is on x, then also same formula applies, but now the power will be reduced from x. Okay, so these are very straightforward, interesting result. You can remember this. whatever power will be given, that thing will come and power will be reduced by 1 unit. Here px to the power n, so px to the power n minus 1, ni h cut will remain. Here also x to the power n was there, x to the power n, it becomes x to the power n minus 1. So once you know about this formula, let us talk about this problem. Let x and p denote respectively the coordinate and momentum operators satisfying the canonical commutation relation xp is equals to I. So you know it should have been I h cut, but in natural unit h cut is taken to be 1, so it becomes I only. Then the commutator of x p sin p. Can you do this? So here is nothing like d dx or d square dx square, some operator, those kind of operator is not there. So even if you do not apply it on side, this will work. Here you may require to apply this infinite series. You know this infinite series cos x 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6 by 6 factorial. So even powers, here sin x, even powers with alternate signs, x minus x cube by 3 plus x to the power 5 by 5 factorial, x to the power 7 by minus x to the power 7 by 7 factorial, and so on. So here you see the powers are odd with alternate signs. So you already know this. So this may be useful here in this problem. Option A you are getting, Muli. Let's do this problem. X p sin p, that's what you have to evaluate. Look, x p, commutation of x p is equals to I. So commutation of x p sin p will become, you see this is x, p is coming first, okay, so p x sin p plus x p sin p. We have already talked about it in the theory classes, so you should be able to understand this. So what is this? X p sin p. Let's take this first one, or let's go for this p, then x sin p is p minus p cube by 3 factorial plus p to the power 5 by 5 factorial minus so on. X p is I, so this is I sin p. So this is equals to p times, you can write it commutation of x p minus commutation of x p cube by 3 factorial plus commutation of x p to the power 5 by 5 factorial and so on plus I sin p. So this is equals to how much? P, commutation of x p is I minus, so 1 by 3 factorial will come. So n I h cat, so 3 I h cat, so 3 h cat p square. So 3 factorial, so 3 getting cancelled. So I p square by 2 factorial. Can I write it? Plus here I p to the power 4 by 4 factorial and so on plus I sin p. If I take common I, what will be this formula? 1 minus p square by 2 factorial plus p to the power 4 by 4 factorial. So this is nothing but the series of cos. So p times cos p plus this sin p. That's matching with option A. Is it clear, guys? Tell me. Harry, Murli, Karthik. Where are those students? Ajay, Megha, all those? चलो आगे बढ़ते. Let's move on to this problem. P is momentum operator and potential energy is given by V of R is equals to minus K by R. If operator A is defined as A equals to minus I sigma dot P cross PVR, then A is equivalent to PVR is the commutation between P and VR. Can I do this? Read this question 2 times. So here what is given? P is a momentum operator and the potential energy V of R is equals to minus K by R. So this is a central force potential, you can say inverse square potential. If operator A is defined as this, then A is equivalent to, look, commutation of PVR. What is given here? Commutation of PVR. You see, what is this thing equal to? P is equals to minus IH cut del del R times, okay. So this is the meaning of this thing. So you have to simplify a little bit. So if you simplify a little bit, this will give you minus RH cut del V by del R R cap. Okay. So this is minus IH cut del del R of minus K by R R cap. So this is minus IH cut K by r cube. Instead of writing vector r means r by r. Sorry, r cap is vector r by modulus of r. You know this one. So this becomes minus k I got k by r cube vector r. Okay. Now let's tackle A. A is equals to minus I sigma dot P cross P V of R. This is equals to minus I sigma dot P cross minus I h cut k by r cube vector r. I square is minus 1 minus plus, so 1 minus is sustaining, h cut k, this is constant by r cube, this is also coming out of the cross product, this is sigma dot p cross r. This is okay. So let us do one thing, let's multiply 2. So we have to divide by 2, P cross R. Now you know h cut by 2 sigma spin, we can write the spin operator as sigma by 2, isn't it? So this becomes 2 h cut k by r cube. You see this r cross p is L, but here it is p cross r, so this minus sign if you observe, then it becomes r cross p. R cross p means L, so S dot L, r cross p is equals to L. In the third step, how negative sign comes, this negative and this negative, positive, I into I square is equal to minus 1, so that is a negative sign. This is matching with option C. First part, this one, you can also apply it on some wave function psi, the way we apply wave function psi, then you will end up getting this result. One term will come, this term will only survive. I have just jumped few steps here. Let's do this one. Given the usual canonical commutation relations, the commutator AB of A and B is. This is good problem. Try to do it. Commutation of AB. Commutation of I times x py minus y px y pz plus z py. So we can write I times commutation of x py y pz plus I times commutation of x py z py minus I times commutation of y px y pz minus y px z py. Now I think you can do, after this much you can easily move forward. So everywhere I is there, so I you can take common. Now you can also keep it because things are not in the good way. So I x py y pz. So first consider this one. So x will come first, py y pz plus I. X remains py plus. Try to understand it, what we are actually doing. First term gives you 0. Yeah, just check whether it is giving you or not. Okay, so many terms we are getting. Py y pz plus y py pz. Can I write it? Each term will be too many terms will come, but they will eventually cancel. So it is x y pz plus x pz y then py plus I x. So look, this calculation is getting little bit lengthy, but that is okay. Py 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 Z Py. There is one mistake in second line, second term. Second line, second term here. Px instead of Py. No, it is fine, na? I xpy ypz, xpy ypz, then I xpy zpy. Next minus I ypx ypz, then minus I ypx zpy. xpy minus xpx. Second line means this line, na? xpy xpx. This one you are talking about is there, na? ypz plus zpy. So what is wrong? It is right only, na? I xpy ypz we took, then I xpy zpy. What is the mistake? Let's see where I was. I should have given it in as homework, okay? It is taking too much time. Plus I zxpy plus xzpy py minus iy, this is px y pz plus px pz minus I y pz y pz. This term will be all get cancelled. px z py okay. Now see, almost all the terms will get cancelled, only few will remain, survive. PY, you see I X PYI, Y PY is IH card, so PYY will be minus IH card, so minus IH card PZ. PY PZ, this is this term is 0. Look, lot of terms will be 0. This term is 0. XY is there, so it is 0. X PZ does not, they do not commute, so this is also 0. PY PI, this is also 0. PY Z, this is also 0. X PY, this will come. Okay. X PY, acha, this is also 0. XZ, this is also 0. Y PX, this is also 0. PX PZ also 0. YY, this is 0. Y PZ, this is 0. pxz, this is 0, pxpy, this is also 0, yz, this is also 0. So what you are left with? You are left with only two terms. This one minus I z, ypy is I h cut px. So you see almost all the terms is getting cancelled. I square is minus 1 minus minus plus. So h cut x pz, x pz. Here also I square is minus 1 minus minus plus z px, x pz plus z px. Wow. This is a good result of hard work. X pz plus z px, h cut x pz plus z px, option C. In last term there is no I term. I into I square is equals to I into I, that is minus 1, right? So here I and I square is minus 1 minus minus plus. So x pz, here also minus minus plus z px, pxz. Which negative sign? I square is equals to minus 1, na? I is equals to square root of minus 1. This is, we know. What is I square? Square root is gone, so minus 1. That is why whenever you see I square, you write minus 1. I into I square, minus 1, minus minus plus. Here I square is minus 1, minus minus plus. Lengthy line. Yeah. Which minus last term? Yeah, this one. Yeah, this minus. Minus, then y z py, y z py, then z into commutation of y py, z into commutation of y py, px. Yeah, are you saying there will be minus here? What is your query? Minus I is taken common here, and all the terms will come plus na inside. What is the confusion? Okay, you can DM me, okay, Harry? We can talk about it later. I think you are getting something. You are misunderstanding something. Let's move on to this problem. If you still have the problem, you can DM me on WhatsApp. Look at this problem. The operator T of epsilon is defined as this, where I is the identity operator, G is the generator of translation, such that T epsilon of psi x is equals to psi of x minus epsilon. Then what is this G equivalent to? Now it is clear. Okay, that is okay. Now do this one. T of epsilon is the operator given by I minus I epsilon by h cut times G. I is the identity operator and G is the generator of translation. So you have to find out the value of G. Okay. So you see, T of epsilon psi of x is equals to given to you psi of x minus epsilon. What you can do, let's put the value of T epsilon, that is I minus I epsilon by h cut times G of psi x is equals to psi of x minus epsilon. Now psi of x minus epsilon, we can expand it. Okay, I psi of x minus I epsilon by h cut G times psi of x. This is psi of x minus epsilon. Let's say we are expanding this psi of x minus, we have to find out ultimately G. So let us expand psi of x minus epsilon up to order epsilon. So psi of x minus epsilon will become psi of x minus d psi by dx time epsilon. So it is like the Taylor series, okay, expanding in Taylor series. And as a result of that, I psi of x minus I epsilon by h cut G psi of x. On the right hand side, psi of x minus epsilon should become psi of x minus d psi by dx time epsilon. Okay, now I of psi x means psi x, so psi x gets cancelled. Now as you can see, minus I epsilon by h cut G psi x is equals to d psi by dx into epsilon. So epsilon is common, that is okay. Psi is common. So what is G? G is equals to h cut by I d dx. Can I write it? If you compare this term and this term, so 1 by I is minus I, so minus I h cut d dx. This is matching with option B. Now if you don't understand this expansion, you can just note this one, that if you have some function f of x plus minus h, if you expand this, this will give you f of x plus minus h into f prime of x plus minus plus h square by 2 factorial f double prime x plus minus h cube by 3 factorial f triple prime x plus so on. So this thing has been utilized here, and here only two terms has been kept for the expansion of psi of x minus epsilon, and this is matching with option B. Okay, now this question came in 2012 June. I think this one you can easily do it. What is the answer of this question? Commutation of x square p square. So if I take this one, x into x, so x into x p square, x p square x. This is 2I h cut p to the power 2 minus 1. This one is 2I h cut p. So this is equals to 2I h cut xp plus px. Wow. So as simple as that. Do you know one operator that is parity operator? What is the job of a parity operator? What it does, if you apply it on some wave function, let's say psi of x, it will make this psi of x as psi of minus x. So what is the job of parity operator? Wherever it will see x, psi of x, it will make it psi of minus x. Okay, just we have already talked about it, just a reminder to this. We are going to discuss a very important topic or thing. What is good quantum number? Good quantum number. This is a little bit off topic, but you should know because this will utilize the commutator relation. So just extra concept. So good quantum number. This is not so important, but just for your information. Okay. Good quantum number are associated with operators that commute with Hamiltonian, that commute with the Hamiltonian. For an example, pi parity is, okay, for an example, parity operator is the operator which commutes with the Hamiltonian, and that is a good quantum number. So parity is commuting with Hamiltonian. How can you prove this? So it should be equals to 0, right? So to show this, let's take this one. Let's apply it on psi. So this is pi h minus h pi of psi. Now if you somehow can show pi h of psi is equals to h pi of psi, then the job is done. Okay, so let's start with pi h of psi, pi h of psi x. If you can somehow show it that it is equals to h pi of psi x, then this will be 0. So pi h of psi x. So what is the Hamiltonian? Hamiltonian, you know, sum of kinetic energy and potential energy. Kinetic energy is minus h cut square by 2m d square by dx square and plus v of x h psi. So psi, and here there is a psi of x. Clear? Now the job is parity operator is to convert psi of x to psi of minus x. So this will become minus h cut square by 2m, instead of d square psi of x, it will get d square psi of minus x. Acha, we have done a fundamental mistake somewhere. It is not psi of minus x, it is at minus psi of x. Okay, sorry. Just a moment. It's a little confusing. Let me just check. I think I told the correct one. Parity operator. Instead of writing incorrect things, let me just check it. Oh, we wrote it correctly before. It is psi of minus x only. If I write it in terms of, let's say, r, this will be psi of minus r. Okay, that was correct. Made a little bit mistake here. Psi of minus x. This will be psi of minus x. Clear? So this is equals to minus h cut square by 2m d square by dx square plus v of x whole thing bracket psi of minus x. So what is this? This is h psi of minus x. So we can write it h psi of minus x is like pi applied on psi of x. So you see pi h of psi x equals to h pi of psi x. So that is why this is 0. Therefore we can say parity is a good quantum number. Tell me if everything is all right. And this was the last thing for today. We'll end the session here if you don't have any question. No question? Hari, Murli, Karthik, everything is all right? So our mathematical tools is almost over. Now you are well equipped with mathematical tools. Now whatever topic we'll discuss, you will find it super easy. You will be easily able to catch those points. Okay, that is the beauty of mathematical tools. If your mathematical tools of quantum mechanics is well done or strong, then the next topic you will find it very easy. In the next section, we'll be dealing with quantum mechanical postulates. That is also very important. But those quantum mechanical postulates will involve these concepts only, commutator, operator, and all those things, which you have learned very well. Okay. So with this note, let us end this session here today. Thank you very much, guys. Already we have seen relation in particle physics. Yeah, the beauty of quantum mechanics is that it is not only restricted to quantum mechanics. It is distributed to statistical, atomic, nuclear. That is why quantum mechanics is so important. Mathematics and quantum mechanics. If you are strong at these two subjects, you will be strong in all other subjects. If you are weak in mathematical physics and quantum mechanics, then you will be weak in other subjects too. Mathematical physics, we have done it in a complete way, detailed way. Everything we have covered. I hope there will be no issue in the mathematical physics. Now we are doing quantum mechanics, and after this, you will be in a very good position to tackle problems. But in quantum, doing problems, careless mistakes comes. Yeah, it will come initially, but it will eventually go away. So just practice as much as possible, and most importantly, revise. Don't think that numerical is not revisable. You have to revise numericals also. One time you do, 2 times you do, 3 times you do, and each time you do, you will get new insights about the problems. So keep practicing and definitely situation will improve. Thank you once again. Bye bye. Take care.